Hey friends, welcome to the YouTube channel All About Electronics. So in this video, we are going to learn about the two of the most common types of random access memories which are quite commonly used inside the computer, that is SRAM and the DRAM. So this SRAM stands for the static RAM while this DRAM stands for the dynamic RAM. And the reason it is known as a dynamic RAM because in case of this memory, we need to perform the periodic refresh cycles. And we will learn more about it when we will see the internal structure of this SRAM and the DRAM at the later part of the video. So now let us see the difference between this SRAM and DRAM in terms of the different aspects. So if you have seen my earlier video of cache memory, then you already might be knowing about this SRAM as well as the DRAM. But anyway, let us see the differences between this SRAM and DRAM in terms of the different aspects. So this SRAM is used as a cache memory inside the computer, while this DRAM is used as a main memory inside the computer. And the reason this SRAM is used as a cache memory is because of its speed. Because this SRAM is the fastest among all the memories. While if you see the speed of this DRAM is faster compared to the primary storage element like hard disk drive, but it is slower compared to this SRAM. So although the speed of this SRAM is quite fast, but if you see in terms of the cost, then in terms of the cost, this SRAM is the costliest among all the memories, while if you see the DRAM, it is cheaper compared to this SRAM. And if you see the density of this SRAM and DRAM, that is the number of memory cells per unit area, then in that case also the SRAM has a lower density compared to the DRAM. So apart from these aspects, the another aspect in which we can compare these two RAMs is the power consumption. So if you see the power consumption of this SRAM, it is lesser compared to the DRAM. But when we operate this SRAM at higher frequencies, then the power consumption of this SRAM as well as the DRAM are comparable. So these are the basic differences between the SRAM and the DRAM. Now let us understand why these differences are present between this SRAM and the DRAM. That means why the speed of this SRAM is fast compared to the DRAM, or let us say why the density of this SRAM is lower compared to the DRAM. So to understand that, we need to see how this SRAM and DRAM works, and to see that we need to understand the internal structure of this SRAM as well as the DRAM. So first of all, let us see the internal structure of this DRAM. So if you see the one bit of the DRAM cell, then it consists of a one transistor and one capacitor. So in case of the DRAM cell, the memory bits are stored in form of the charge across this capacitor. So by charging and discharging the capacitor, we can know that whether the bit that is stored inside this capacitor is logic 1 or logic 0. So now in case of this DRAM cell, we can access this capacitor by using this pass transistor. So when this pass transistor is turned on, then we can read the capacitor data or we can write onto this capacitor. And when this pass transistor is off, then the charge across the capacitor should remain as it is. So in ideal case, this capacitor should not lose its charge. But in actual case, if you see, there will be some leakage current, and because of that, the capacitor will lose its charge gradually. And that is the reason this dynamic cell requires the periodic refresh cycles. And that is the reason behind it why this memory is known as the dynamic RAM. So now as we know about the internal structure of this dynamic RAM, let us see how read and write operations are being performed on this dynamic RAM. So like I said, to read the data of this DRAM, first of all, we need to turn on this pass transistor, and that can be done by applying the voltage to this word line. So once the voltage is being applied to this word line, then the charge across this capacitor will be available at this bit line. So just by using the sense amplifier, we can read the voltage that is available at this bit line. So now if you observe this read cycle, in this read cycle, once this pass transistor is on, then the data or the charge across this capacitor will be available at the bit line. So eventually this capacitor will lose its charge during the read operation. So such kind of read operation is known as the destructive read operation. And to avoid that, we need to perform the refresh operation after every read cycle so that the capacitor can get its original charge. So now to increase the read operation speed, these bit lines are charged with the finite voltage. Now let us understand why this precharge is very important. So let us say initially the voltage across the capacitor is 2 volt, and the 2 volt represents the logic 1 and the 0 volt represents the logic 0. So once the read operation starts, this pass transistor will be turned on and the voltage across this capacitor gradually will be available at the bit line. So the bit line will start charging from the 0 volt to the 2 volt, and once it will reach from 0 to 2 volt, then the sense amplifier will get to know that the voltage across the capacitor is a 2 volt or logic 1. But instead of that, suppose if we have pre-charged this bit line to the 1 volt, then the time that is required to reach from 1 volt to the 2 volt will be almost half. So in this way, by pre-charging this bit line by some finite value, we can reduce the read time or we can increase the read speed. And further we can increase this read speed just by sensing the trend in which this bit line voltage is going. So instead of waiting for this bit line to reach from 1 volt to the 2 volt, suppose if we just measure the incremental voltage across this bit line and if we amplify it after this sense amplifier, then the time of this read operation will further reduce. So in this way, by using these methods, we can reduce the read time of this dynamic RAM. So now similarly, let us see how the write operation is being performed. So during the write operations, all the bit lines are being pre-charged with some finite value, and for the particular bit line on which we want to write, the bit voltage is applied to that particular bit line. So let us say we want to charge this capacitor, then the bit voltage will be applied to this particular bit line, and then after this pass transistor is turned on, so whatever voltage that is available at this bit line will be transferred to this capacitor, and in this way we can write on this DRAM. So this is how read and write operations are being performed on this DRAM. So now as this DRAM involves the capacitors, so the reading and writing speed of this DRAM depends upon the charging and discharging time of these capacitors. Similarly, let us see the internal structure of this SRAM and let us see how reading and writing is performed on this SRAM. So if you see the internal structure of this SRAM, it consists of 6 transistors. So out of the 6 transistors, the 2 transistors are the pass transistors, which will give access to the bit lines, while the remaining 4 transistors are the 2 cross coupled inverters. So here this transistor 1 and 2 is the first CMOS inverter pair, and the transistor 3 and 4 are the second inverter pair. So if you see the simplified circuit, then the simplified circuit will look like this. So in case of this SRAM cell, the memory bit is being stored between these 2 cross coupled inverters. So let us say if we have latched logical 1, then at the output of the first inverter we will have a logic 0, and again at the output of the second inverter we will have a logic 1. So as far as the power is supplied to this SRAM, the logic 1 will be get circulated between these 2 inverter pairs. So unlike in case of the dynamic RAM cell, we do not require any kind of refresh cycles during this SRAM operation, and that is the reason this SRAM is known as the static RAM. So apart from this 6 transistor design of this SRAM cell, we also have a 4 transistor design. So in case of this 4 transistor design, the PMOS are replaced by the high impedance resistors. So in this way, by using this 4 transistor design, we can reduce the number of bits that is required for the 1 bit of storage. But the disadvantage of this 4 transistor design is that the continuous power will be get dissipated across these resistors. So whenever we require the less power consumption, then the 6T design is more preferred over this 4 transistor design. So as you can see, in case of this SRAM cell, the number of transistors that is required is 6 times more compared to the DRAM, and that is the reason the density in case of the DRAM is more than the SRAM cell, and that is also reason why this SRAM is costlier compared to the DRAM, because the cost per bit in case of the SRAM will increase compared to the DRAM. So that is being said, now let us understand how read and write operations are being performed on this SRAM. Now to perform the read operation, first of all, these 2 pass transistors are turned on by applying the voltage to this word line. So once these pass transistors are turned on, then whatever voltage that is available at this point, let us say Q, that will be available at the bit line, and whatever voltage that is available at this point, let us say the Q bar, that will be available at the bit line. So suppose at this point, let us say we have a logical 1, then at the bit line we will get a logical 1, and at this point we will get a logical 0, and using the sense amplifier we can sense this voltage and we can read that voltage of this SRAM cell. Now you might ask that this can be performed only by the single bit line, so what is the need of having a 2 bit lines? So the 2 bit lines are required to increase the speed of this read and write operations. So let us understand how these 2 bit lines will enhance the speed of this read and write operations. So here in case of the SRAM also, these bit lines are pre-charged with some finite value. So let us say if this SRAM has a 2 volt as logical 1 and 0 volt as logical 0, then generally these bit lines are pre-charged with a voltage of 1 volt. Now let us also assume that the voltage that is being read through this SRAM is logical 1. So at this point we will have a 2 volt of voltage, and at this point we will have a 0 volt of voltage. So as soon as this pass transistor is turned on, the voltage at the bit line will be equal to 2 volt. But this transition from 1 volt to 2 volt will take some time. Similarly, at this bit line bar, we will have a voltage from 1 volt to the 0 volt, and this transition will also take some time. So instead of waiting for the voltage to reach from 1 volt to 2 volt and from 1 volt to 0 volt, if we simply see the trend in which the voltage is going, then we can increase the speed of this read cycle. So as you can see here, we are taking a difference between the bit line and the bit line bar voltages. So here if the voltage is increased from 1 volt to the 1.1 volt, and let's say here the voltage is reduced from 1 volt to the 0.9 volt, then if we just differentiate these two voltages and amplify it, then we can easily sense that voltage, and in this way we can increase the read speed or reduce the read time. Similarly, let us see how the write operation is being performed. So during the write operation, whatever voltage we want to write on this inverter pair, we need to apply that voltage to these bit lines. So let us say we are applying a logical 1 to this bit line, and the initial voltage or the initial bit that is being stored inside this inverter pair is logical 0. So at the bit line bar we will apply the logical 0. So now whenever we turn on this pass transistor, then the bit line voltage will be applied to this inverter, and this inverter will try to reduce the voltage of this bit line to the logical 0. But at the same time, if you see over here, this logical 0 will be applied to the input of this inverter. So that will drive the output of this inverter to the logic 1, and that logic 1 will drive the output of the first inverter to the logic 0. So in this way, the value of logical 1 will be latched inside this inverter. So in this way, by having the 2 bit lines, we can drive the bit line voltage into this inverter pair very easily. So by having the 2 bit lines, we can increase the speed of read and write operations. So far as we have seen, in case of this SRAM cell, it do not involve any kind of capacitors. So the transition from 1 to 0 will be faster in case of this SRAM compared to the DRAM, where it involves the charging and discharging of the capacitor, and that is the reason this SRAM is quite faster compared to the DRAM. So as we have seen so far, this SRAM consists of 6 transistors, while the DRAM consists of only 1 transistor, and that is the reason this SRAM is quite costly compared to the DRAM, as well as the density of this SRAM is low compared to the DRAM. And as this DRAM involves the capacitor charging and discharging as well as the refresh cycles, so the speed of this DRAM is less compared to the SRAM. So this is all about the differences between SRAM and the DRAM. So in the next video we will learn more about the dynamic RAM. We will see the different types of dynamic RAMs, and we will also understand the timings and the latencies in the DRAM. So I hope in this video you understood the basic differences between the SRAM and the DRAM, and how read and write operations are being performed on this SRAM as well as the DRAM. So if you have any question or suggestion, do let me know in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.